let's discuss some examples on circular motion. So let's say we have a string and this string the string can take a maximum tension of 20 newtons. So you have a string, and if the tension of the string exceeds 20 newtons, it's going to break. And you tie a stone to it, and let's say the mass of the stone is 100 grams, and you move it in a circle. Now the question is, at what velocity will the string break? So see, as you increase the velocity or speed of the stone, the string is going to get more and more tighter, and after a while it's going to fail. We can do this experiment where we can tie a stone, and if no one is around, we can just increase the speed of the string, and we'll see eventually the string will break. And we have already discussed that the tension in the spring provides the centripetal acceleration, and this centripetal acceleration is given as mv square over r. We have not mentioned, but let's say the length of the string is also given, and this is 1 meter. Okay, so this is 1 meter. So what is the maximum velocity with which you can swing the stone? Well, how to calculate this maximum velocity? We know that the maximum F can go, which is because of tension, and which is actually tension, is 20 newtons. This equals, mass is given 0.1 kilograms, v square we have to find, divided by r, which is the radius, and that is 1 meters, and that gives us v square equals 200, which means v is square root of 200, or you can also say 10 square root 2 meters per second. So this is the maximum velocity by which you can swing the stone without breaking the string. So that is one example. Let's take one more example. Let's say we have a racetrack, and this racetrack has a radius of 40 meters, and there is a car which is running on this track, and this car is running on the ground, so the coefficient of static friction is, let's say, 0.2. And the question is, how fast can the car go? So you see, if you see a car from the back, this car is moving in a circle and has an acceleration inward because of centripetal acceleration, which is v square over r. So we have to calculate v max. What is the maximum speed? Also, what is that thing that is going to provide this acceleration? There should be a force, the centripetal force. So what is that thing that is going to provide the centripetal force? Well, it's the thing that will provide the centripetal force will be friction. it's friction that is going to provide this centripetal force. What is the centripetal force? We just have said it's mv square over r. Alright, so we know that mv squared over r should be equal to the maximum frictional force. So the maximum frictional force will give the maximum velocity, because anyway m and r are constant. Now what is the maximum frictional force? You see, the car is not really moving in the radial direction, up and down, so that's why we have mentioned the static friction here. There is no dynamic friction, the car is not slipping, is running, so in this particular direction there is no slipping, so we can safely use coefficient of static friction. So, and what is the maximum frictional force? Well, we already know that the maximum frictional force is given as mu times n. What is n? N is the normal reaction. And what is normal reaction? Well, we already know that if we make a free body diagram, it's always a good idea to make free body diagram whenever you solve a mechanics problem. And if you write Newton's equation, and because there is no motion in the y direction, there is no net force acting, and because there is no net acceleration, we know that n equal mg. So that gives us mu mg. So mu mg will be equal to mv square over r, and that gives us 0.2 g equals v square divided by 40, or v square equals 8g. that is means v is square root of 8g meters per second. So this is v max, this is the maximum speed by which the car can go. As a matter of fact, when the car is standing, there is no friction acting in the radial direction, radially inward direction. There is no friction. Why? Because there is no centripetal force required, because car is not really going in a circle. But when car speeds up, what happens? As it speeds up, it starts going in a circle. When it starts going in a circle, there is a requirement for a centripetal force, and this centripetal force is this, which depends on the velocity of the car. As the driver keeps on increasing the velocity of the car, what happens? That this force also keeps increasing, and this force is being provided by the friction, and friction keeps increasing to provide this force. Friction really cannot go above a maximum value, which is given by mu n. So when friction reaches mu n, this is the maximum centripetal force that friction can provide. And that's why we have set up this particular equation, and if we solve this, we get this maximum velocity.